So there are a couple ways of doing the next step, which is, we can multiply the vector, we can deconstruct and reconstruct the length of the vectors. We can simply scale the length of the vectors. But when you do something like a scale, you also have to use more vectors in order to get the right orientation. So Grasshopper actually makes this pretty easy for us, at least right now it does, because we can use Amplify, which I don't really know where it is. So let's type in oh, there it is. So it's probably under vector, amplitude. There it is. So let's take a look at that. We've got a base vector and then an amplitude. So what is it really doing? What do you think it does?
It makes it to a certain length.
Right, by doing what?
Amplifying it?
Right, an amplification is a really fancy word for what?
Multiply?
Right, multiplying. So it's kind of the same as deconstructing your vector, going into operators and using a multiplier, and then reestablishing the length part and then reconstructing the vector. But this does it for you. So we're going to plug in vector, and then we're going to create an amplification, which is like 0 less than 4, less than 8, I guess. I don't know. And then I'll plug that into A, and then that gets plugged into T. So I'll turn this back on, and there's our difference. So when we move amplitude now, if I go down at 0, it's not technically a multiplier, because if we multiplied by 0, it would be 0. Well, actually, yeah, no, I guess it is still, because if it's multiplying, it's not a multiplier. That's what I'm saying.
The space between each panel, technically?
It does, but if you were to multiply the length of the vector by 0, then it becomes 0 and it's non-existent.
Oh, that's unfortunate.
So it won't register 0, but it will multiply it by its base length. So if you do 1, it's going to increase the length by a factor of 1, and it looks like it's going to be moving it. Okay? So every increment is moving it 1 unit out. So I guess it's an addition factor, not a multiplier. My mistake. But same principle. Okay? So essentially what I want you to understand here is that while I take this vector display and then I plug it into this one, ooh, look at that. What it's doing when you look at the second one is it's not actually changing the vector. It's creating a mathematical relationship between the original vector and the new one. Now later, when we begin to get into like patterning on warped surfaces and stuff, we're going to start looking at amplify vector, or we're going to start looking at vector relationships as measurements as well. So that's just sort of a preface for that. Okay. So are there any questions at this point? Was that this? It's just another vector display. I just copied this and placed it over here. Okay, so very, very simple for this step. I'm going to actually just stop this here, make sure everybody gets to this point before we move on to our next exercise, which is, what was I doing again? Oh yes, the grid and the space frame, which you'll love.